Okay, now let us do question number 8. If log x upon b minus c equal to log y upon c minus a equal to log z upon a minus b. This is the given condition. We are asked to prove x to the power b plus c times y to the power c plus a times z to the power a plus b equal to 1. So we are asked to prove this is equal to 1. Okay, so let us use the given condition. Log x upon b minus c equal to log y upon c minus a equal to log z upon a minus b. This is equal to this and this is equal to this. All these three terms are equal to each other, isn't it? So now let us suppose this is equal to k. See, okay? Now this is equal to this and this is equal to this and this is equal to k. So that means this is equal to k, this is equal to k and this is equal to k. Okay, let us write separately. Log x upon b minus c equal to k. Similarly we write this log y upon c minus a equal to k and log z upon a minus b equal to k. Okay, now what we do is we multiply this b minus c to the other side of the equation, cross multiplication. Okay, b minus c into k. Okay, log x equal to k into b minus c, k b minus c. Similarly we do the same thing here. Log y equal to k into c minus a, log z equal to k into a minus b. Now let us multiply both sides of this equation with b plus c. Okay, because we have b plus c as power, isn't it? So we multiply b plus c with b plus c to both sides of this equation. Now this becomes b plus c into log x equal to k into b minus c into b plus c. I have multiplied both sides of this equation with b plus c. Okay, left hand side also, right hand side also. Same thing we do here in this equation. We multiply with c plus a because we have c plus a here. C plus a into log y equal to k into c minus a. We already have it, c minus a. Now we multiply with c plus a. C plus a and c plus a, both sides of this equation. Same thing we do here also. We multiply with a plus b because we have a plus b here, or a plus b into log z, a plus b into log z equal to k into a minus b into a plus b, isn't it? Now if we have n log m, we can write this as log m to the power n, isn't it? The number before log will go as power. Okay, so we do the same thing here. B plus c log x means log x to the power b plus c. This b plus c will go as the power of x. Log x to the power b plus c equal to this log x to the power b plus c equal to k into, we apply the formula here. If we have a plus b into a minus b, we can write this as a square minus b square, because a square minus b square means a plus b into a minus b. So this is a plus b, a minus b. We can write a square minus b square, isn't it? A square minus b square. This is equation 1. Okay, now we do the same thing here also. Log y to the power c plus a, log y to the power c plus a equal to k into c minus a. C plus a is c square minus a square, isn't it? This is equation 2. Okay, the same thing we do here. Log z to the power a plus b equal to k into a minus b. A plus b is k k into a square minus b square. This is equation 3. Now we will add this equation 1, 2 and 3. Okay, adding equation 1, 2 and 3. When we add equation 1, 2 and 3, we have to add all the left hand side together, and similarly we add all the right hand side together. Okay, so in the left hand side we have log x to the power b plus c plus log y to the power c plus a, log y to the power c plus a plus log z to the power a plus b, log z to the power a plus b. All these three terms of the left hand side are added together. Okay, so equal to, in the right hand side we have k into b square minus c square plus k into c square minus a square plus k into a square minus b square. Okay, we add all these terms together. K into b square minus c square plus k into c square minus a square, c square minus a square plus k into a square minus b square, a square minus b square. Okay, now if we have log a plus log b plus log c, okay, if bases are not given, we must assume the bases are same. Okay, the bases are equal, and if the bases are equal and there is a plus sign in between logarithms, what we do is log a into b into c. A into b into c is abc, isn't it? So we do the same thing here. Log x to the power b plus c plus log y to the power c plus a plus log z to the power a plus b. Bases are not given, means we must assume the bases are equal. So we can add these logarithms in this way. Log x to the power b plus c times y to the power c plus a times z to the power a plus b. Okay, equal to, now let us multiply both these numbers with k. K into b square, kb square, plus into minus is minus, k into c square is kc square, plus this plus we write here, k into c square, kc square, plus into minus, minus, k into a square, ka square, this plus we write here, k into a square, ka square, plus, sorry, plus into minus, minus, k into b square, kb square, isn't it? Now we have plus kb square here and minus kb square here. So let us cancel this. This becomes 0. Minus kc square and plus kc square. This also becomes 0, isn't it? Minus ka square and plus ka square. This also becomes 0. So we have log x to the power b plus c times y to the power c plus a times z to the power a plus b equal to, we have 0 in the right hand side, 0, isn't it? Everything is cancelled, so we write 0, or log x to the power b plus c times y to the power c plus a times z to the power a plus b equal to, instead of 0 we can write log 1, isn't it? Because the value of log 1 is always 0. Log 1 means 0. So instead of 0 I am writing log 1. Okay. Now we can leave log from both sides. We have log in the left hand side also, and we have log in the right hand side also. Bases are not given, means we assume bases are equal. Okay. Bases are not given means bases will be equal. So this we write here because we have left this log. X to the power b plus c times y to the power c plus a times z to the power a plus b equal to, leaving this log, we have 1 in the right hand side. So this is what we were asked to prove, isn't it? X to the power b plus c times y to the power c plus a times z to the power a plus b equal to 1. Hence proved. Okay, question number 8b. If log x upon b minus c equal to log y upon c minus a equal to log z upon a minus b, then so we are asked to prove this is equal to 1. Okay, x to the power b square plus bc plus a square times y to the power c square plus a plus a square times z to the power a square plus ab plus b square equal to 1. So let us use the given condition. Or log x upon b minus c equal to log y upon c minus a equal to log z upon a minus b equal to k, say. Okay, so this is equal to this, and this is equal to this, and this is equal to k. All these three terms are equal to each other, and this is equal to k. Means this must be equal to k, and this is equal to k, and this is equal to k. Now let us write separately. Log x upon b minus c equal to k. Similarly, log y upon c minus a equal to k, and log z upon a minus b equal to k. Now let us multiply this b minus c to the other side of this equation. Log x equal to k into b minus c, k into b minus c. This b minus c multiplies with k, cross multiplication. Okay, log y equal to k into c minus a, isn't it? C minus a. Same thing here, log z equal to k into a minus b. Okay, now we have x to the power b square plus bc plus c square, isn't it? Now, so let us multiply with this b square plus bc plus c square to the left hand side of this equation. Okay, this equation. Or b square plus bc plus c square into log x equal to k into b minus c. This was already here. Now we multiply both sides of this equation with this number, isn't it? So b square plus bc plus c square. Okay, similarly in case of y, we have the power of y c square plus ca plus a square. So we multiply both sides of this equation with c square plus ca plus a square. Okay, c square plus ca plus a square into log y, this log y equal to this k into c minus a. This was already there. Now I am multiplying with this number to the both sides, isn't it? So c square plus ca plus a square. Same thing we do here. We have a square plus ab plus b square. So let us multiply both sides of this equation with a square plus ab plus b square. Okay, a square plus ab plus b square into log z equal to k into a minus b was already there. Now we multiply with this number, a square plus ab plus b square. Now this becomes, if we have n log m, this becomes log m to the power n, isn't it? So we apply this rule here. Here log x to the power, this number goes as power. Okay, b square plus bc plus c square, okay, equal to k into, now this is a minus b into a square plus ab plus b square. We assume b as a and c as b. Okay, so this becomes a minus b into a square plus ab plus b square. So if we have a minus b into a square plus ab plus b square, we can write this as a cube minus b cube, isn't it? So this has k into a is b A is B and B is C. A cube minus B cube, isn't it? This is equation 1. We do the same thing here. This becomes log y to the power c square plus ca plus a square. C square plus ca plus a square. Okay, this goes as power equal to k into now a minus b into a square plus ab plus b square. This is k into a cube minus b cube, isn't it? This is equation 2. And the same thing we do here. Log z to the power a square plus ab plus b square equal to k into a minus b into a square plus ab plus b square is a cube minus b cube. Okay, this is equation 3. Now we add all these 3 equations together. Okay, adding equation 1, 2 and 3. Adding equation 1, 2 and 3. So the left hand side of all these 3 equations we add together. Okay, first we have log x to the power b square plus bc plus c square, b square plus bc plus c square equal to we add the left hand side first. Okay, plus log y to the power c square plus ca plus a square, log y to the power c square plus ca plus a square, c square plus ca plus a square, plus now we have log z to the power a square plus ab plus b square, a square plus ab plus b square. This is the left hand side of all these 3 equations we have added together. Now we add the right hand side of these equations as well. Right hand side we have this plus this plus this, isn't it? So we write first, let me write here, k into b cube minus c cube, b cube minus c cube, okay, plus k into c cube minus a cube, k into c cube minus a cube, plus k into a cube minus b cube, k into a cube minus b cube. We have added the left hand side of these 3 equations together and the right hand side also together. Okay, now we sum up this. Left hand side we have log suppose this is log a plus log b plus log c, then we can write log a b c, isn't it? So we write this log x to the power b square plus bc plus c square into y to the power c square plus ca plus a square into z to the power a square plus ab plus b square equal to, in the right hand side we have k into b cube, kb cube minus, plus into minus is minus, k into c cube, kc cube, plus this plus we write here, k into c cube, kc cube, plus into minus is minus, k into a cube, ka cube. Okay, this plus we write here, k into a cube, ka cube, plus into minus is minus, k into b cube, kb cube. This plus kb cube and minus kb cube, same number, opposite sign, we can cancel this. This becomes 0. Minus kc cube and plus kc cube can be cancelled. Minus ka cube and plus ka cube, this also can be cancelled. So nothing is left in the right hand side, 0. Okay, log x to the power b square plus bc plus c square times y to the power c square plus ca plus a square times z to the power a square plus ab plus b square equal to 0. Nothing is here, so we write 0. Or log x to the power b square plus bc plus c square times y to the power c square plus ca plus a square times z to the power a square plus ab plus b square equal to, instead of 0 I can write log 1, because log 1 means 0, isn't it? So we can leave log from the left hand side and log from the right hand side. Log, okay? Both of these logarithms have no bases, means bases are equal. So leaving log from both the sides we write, therefore x to the power b square plus bc plus c square times y to the power c square plus ca plus a square times z to the power a square plus ab plus b square equal to 1. Okay, so this is what we were asked to prove. So this is proved. Question number 9. So this is the given condition. We are asked to prove this. Now let us write the given condition first. A to the power 3 minus x times b to the power 5x equal to a to the power 5 plus x times b to the power 3x. Okay. Or what we do is we keep this b to the power 5x in the left hand side. We bring this to the left hand side by cross multiplication, so it goes to the denominator. B to the power 5x we already have in the left hand side. This will go to the denominator, okay, by cross multiplication. B to the power 3x equal to a to the power 5 plus x. This was already in the right hand side. Now this number will go to the denominator, a to the power 3 minus x. A to the power 3 minus x. 3 minus x, okay. Now if we have a to the power m divided by a to the power n in indices, we can write this as a to the power m minus n, isn't it? Bases are same and there is division sign, then we can write this plus n as minus n, okay. b same base means b to the power 5x minus this 3x equal to the same thing we can apply here, a to the power 5 plus x minus 3 minus x, 3 minus x, m minus n, okay. Or b to the power 5x minus 3x is 2x, okay. This equal to a to the power 5 plus x minus into plus. There is plus sign before 3, so minus into plus, minus 3, minus into minus, plus x. Or b to the power 2x equal to a to the power x plus x is 2x, 5 minus 3 is plus 2, 5 minus 3 is 2, okay. Now let us put logarithm to both sides of this equation, logging both sides, okay. Log b to the power 2x equal to log a to the power 2x plus 2, isn't it? So if we have log m to the power n, we can write this as log, this n comes before log, and log m, isn't it? So same thing we are going to apply here. Or 2x comes before log, 2x log b, 2x comes before log b, okay, 2x log b equal to 2x plus 2, 2x plus 2, and then log a, okay. This 2 we can cancel with this by taking common, or 2x log b, 2x log b, okay. I am writing this as it is. Common, 2 is taken common, so we have 2x here, 2 is taken out, x remains within the bracket, plus 2 is taken out, so 2 1s are 2. 2 into x, 2x plus 2 1s are 2. 2 is taken common. Log a. Okay. Now this 2 and this 2 can be cancelled because this 2 goes to the denominator by cross multiplication, isn't it? So the number in the denominator, number in the numerator can be cancelled. So let us cancel here itself. Okay. Now we have x log b in the left hand side, and in the right hand side we have log a into x plus 1. So log a into x is x log a plus log a into 1 is log a. Okay. Now we bring this x log a to the left hand side, or x log b, this was already in the left hand side, we bring this to the left hand side, minus x log a equal to log a, isn't it? So we have x common here, we can take x common. Within the bracket we have log b minus log a, okay, equal to log a. X is taken common, so x we took common, log b minus this x is taken common, log a. Let me write here this x we have in the left hand side, x log b minus log a. Suppose if we have log m minus log n, we can write this as log m upon n, isn't it? So we are going to use the same rule here. This x is outside the bracket, we write as it is, log m minus log n. Okay, log b is m minus log n. So this becomes log b upon a, isn't it? Log b upon a equal to, in the right hand side we have log a. So this is what we have here, we were asked to prove, isn't it? So this is proved. Question number A of 10. This is the given equation and we are asked to solve this equation. Solve means we are asked to find the value of x. Okay, we can see x here, 4 to the power x, isn't it? So we will find the value of this x. To solve this question, let us first learn to convert logarithmic equation to exponential form. So if we have log x to the base a equal to m, we can write this as x equal to a to the power this m. This is logarithmic equation and this is exponential equation. Okay, logarithmic equation can be converted to exponential equation like this. This x will remain here, this base a we write here, this m becomes the power. Now what we do is we assume everything within the big bracket as x. Okay, so we have log x to the base 8 equal to 1 by 3. Log x, everything within the big bracket is x. Log x to the base 8 equal to 1 by 3. So this becomes x equal to 8 to the power 1 by 3, isn't it? X equal to 8 to the power m. This becomes power, this 8 goes to base. Okay, so x is log base 2 curly bracket log base 3 and then 4 to the power x plus 17 curly bracket close equal to, this is x, x is equal to base we write here and power 1 by 3. Okay, so base 8 comes here. Let me rewrite this, okay, or I will do here itself. 8 means 2 4s are 8, 2 2s are 4, means 1 2 3, 2 cube. Okay, 8 means 2 cube. So instead of 8, can I write 2 cube? Obviously yes, isn't it? So this is 2 cube into 2 cube into 1 by 3. 1 by 3 is already there as power, isn't it? So this 3 and this 3 cancels out. Now we have 2 to the power 1. 2 to the power 1 is 2, isn't it? Log of, now we assume this as x. Everything within the curly bracket is x. Log x to the base 2, okay? Log x to the base 2 is 2 to the power 1. 2 to the power 1 means 2, okay? 2 to the power 1 means 2. Log x to the base 2 is equal to 2. Log x to the base 2 equal to 2. This means this x we write here. What is x? Log base 3, 4 to the power x plus 17. This is x. X equal to base 2 raised to power this 2, isn't it? Or 2 squared is 4. Now we have log x to the base 3 equal to 4. This is actually 4, isn't it? 2 squared is 4. Log x to the base 3 is 4. This means this x we write here 4 to the power x plus 17. X equal to this base 3 we write here, and this comes as power, isn't it? Now we have 4 to the power x plus 17 equal to 3 to the power 4 means 81. 3 to the power 4 is 3 into 3 into 3 into 3. 3 3 is a 9, 3 3 is a 9. 9 9 is a 81. Okay? Or 4 to the power x equal to 81 plus 17 becomes minus 17 on the other side. Or 4 to the power x equal to 81 minus 17 is 11 minus 7 is 4. This 7. This becomes 7. 7 minus 1 is 6. 64, isn't it? So 64 means 4 1s are 4. I am trying to make the multiple of 4 because we have 4 here as base, isn't it? So 4 1s are 4, 5 6, 2 in hand, 4 6 are 24, 4 4s are 16, 1 2 3, 4 cube, okay? Or 4 to the power x equal to 64 means 4 cube. Now we have bases equal. If bases are equal, then powers will also be equal. Therefore, x equal to 3. So we were asked to find the value of x from this equation. The value of x is 3, okay? Question number 10b. So this is the given equation. We are asked to find the value of x from this equation, okay? So let us solve this. Log x to the base 8, isn't it? If we have log a to the base b, we can write this as 1 upon log b to the base a, isn't it? Log a to the base b becomes log b to the base a if we take this number to the denominator. Same thing we apply here. 1 upon log 8 to the base x plus here also 1 upon log 4 to the base x plus this we leave as it is, log x to the base 2 equal to 11, okay? Now, or 1 upon log 8. 8 is 2 cubed. 2 into 2 into 2 gives 8. So 2 cubed to the base x plus 1 upon log 4 means 2 squared. So this x we write here base plus log x to the base 2 equal to 11. Okay. 1 upon, if we have log m to the power n, then we can write this as n log m, isn't it? So we apply the same rule. This 3 we bring before log. 3 log 2 to the base x, okay, plus we do the same thing here. 1 upon 2 log 2 to the base x. This 2 comes before log, plus log x to the base 2 equal to 11. Okay. Now we take this log to the numerator. So 1 upon 3, we already have 1 upon 3. If we take this log to the numerator, this becomes log x to the base 2. Log x to the base 2 plus this 1 upon 2 is already here. If we take this log to the numerator, this becomes log x to the base 2 plus log x to the base 2 equal to 11, isn't it? Or n log m can be written as log m to the power n, isn't it? We apply the same rule here. Log x to the power 1 by 3. This goes as power, okay? Base 2 plus log x to the power, this becomes power 1 by 2 base 2 plus log x to the base 2 equal to 11. Now if we have log a plus log b plus log c, then we can write log a b c, isn't it? Log a into log b into, log a into b into c, or this is log a plus log b plus log c, okay? Bases are same, so we multiply this. Log base 2 x to the power 1 by 3 times x to the power 1 by 2 times x, means x to the power 1, okay, equal to 11. Let me continue here. So this is log base 2 or log base 2. Now x, bases are same, and if bases are same, when we multiply these numbers, powers will be added, isn't it? Suppose if we have a cube into a square into a to the power 5, then we can write this as a to the power 3 plus 2 plus 5, isn't it? A to the power m into a to the power n is a to the power m plus n. We learned this in indices, isn't it? So we're going to apply this. So x into x into x, we write x to the power 1 by 3 plus 1 by 2 plus 1. 1 by 3 plus 1 by 2 plus 1, okay, equal to 11. 11 is in the right hand side, isn't it? Or log base 2 x to the power 3, 2 and we have 1 in the denominator of this number. 3, 2 and 1. LCM is 6. 3, 2 are 6, 2 1s are 2 plus 2, 3 are 6, 3 1s are 3 plus 1, 6 are 6, 6 1s are 6, okay, equal to 11. Or log base 2 x to the power 2 plus 3 is 5. 5 plus 6 is 11. 11 to the base 6 equal to 11. Okay, log base 2 we wrote here. X to the power 2 plus 3 is 5. 5 plus 6 is 11 upon 6. 11 upon 6 equal to 11. Now this we can write as x to the power 11 upon 6 equal to 2 to the power 11, isn't it? Or x equal to 2 to the power 11 we already have here, into this 11 upon 6. If we take this power to the right hand side, this becomes 6 upon 11, okay? Suppose if you have a to the power 1 by 2 equal to m, then we can write this as a equal to m 2 upon 1. 2 upon 1 means 2, okay? Suppose if you have a to the power 3 by 4 equal to b, then we write a equal to b to the power 4 by 3. When we take power to the other side, the numerator of the power becomes denominator and denominator of the power becomes numerator, okay? So 11 upon 6 becomes 6 upon 11 if we take this power to the right hand side. This 11 and this 11 cancels out, or x equal to 2 to the power 6. 2 to the power 6. 2 to the power 6 means 2 into 2 into 2 into 2. 1, 2, 3, 4, 5 and 6. 2 to the 4, 4 to the 8. 2 to the 4, 4 to the 8. 8 into 8 is 64. Or x equal to 64. So this is the value of x. Question number 11. So that the value of log 2 to the base 10 lies between 1 upon 4 and 1 upon 3. So we are asked to prove the value of log 2 to the base 10 lies in between 1 upon 4 and 1 upon 3. Okay. So how do we solve this? First we find the LCM of 4 and 3. Okay, the denominators of these two numbers, 4 and 3. LCM of 4 and 3 is 4 1s are 4, 3 comes here, 3 1s are 3, isn't it? 4 3s are 12. So 12 becomes the LCM. Now let us convert this to exponential form. Okay, first let us write let log 2 to the base 10 equal to x. I am supposing log 2 to the base 10 is equal to x. Okay, now let us convert this to exponential form. This 10 we write here as base, this x comes here as power, equal to this 2 goes here, isn't it? 2 equal to this 2 equal to base to the power this 10 to the power x. Okay, now 10 to the power x equal to 2, isn't it? And the LCM of this 4 and 3 is 12. So we multiply with the power of 12, okay? Or 10 to the power x we already have here into 12 power 12, okay, equal to 2 to the power 12. Okay, so this is, or 10 to the power x into 12 is 12x equal to 2 to the power 12. 2 to the power 12 means 1 2 3 4 5 6 7 8 9 10 11 and 12. 2 to the 4, 4 to the 8, 2 to the 4, 4 to the 8, 2 to the 4, 4 to the 8, and 2 to the 4, 4 to the 8. 8 is the 64, 8 is the 64. Now we multiply 64 into 64. 4 4 is the 16, 1, 4 6 is the 24, plus 1 is 25, 6 4 is the 24, 4, 2 in hand, 6 6 is the 36, 37, 38. So this is 6, 5 plus 4 is 9, 8 plus 2 is 10, 3, 4, 4096. 4096, isn't it? 10 to the power 12x equal to 4 to the power, 10 to the power 12x equal to 4096. Okay. Now this 4096 is lesser than 10,000, isn't it? 1 2 3 4. 4096 is lesser than 10,000 but greater than 1000. Okay, 4096 is greater than 1000 but lesser than 10,000. So 4096 is equal to 10 to the power 12x. So this means, or we can write 1000 is lesser than 10 to the power 12x, lesser than 10,000. Instead of 4096 I am writing this, okay, because 4096 is equal to this. So instead of 4096 I am writing 10 to the power 12x. 10 to the power 12x is lesser than 10,000 but greater than 1000, isn't it? So let me solve individually to make clear. Okay, so if we have 1000 10 to the power 12x, if we have this 10 to the power 12x is greater than 1000, isn't it? So we can write this as 10 cube greater than 10 to the power 12x, isn't it? So this means 12 10 10 same, 12x is greater than 3. Okay, this means we can write this 3, this 12 comes here, greater than x, lesser than x, 3 upon 12, this 12 comes here, 3 upon 12 is lesser than x, 3 1 is 3, 3 4 is 12. Okay, so 1 upon 4 is lesser than x. Similarly, 10 to the power 12x is lesser than 10,000, isn't it? 10 to the power 12x is lesser than 10,000. This means 10 to the power 12x is lesser than 10 to the power 4. So 10 10 are equal. This means 12x is lesser than 4, or x is lesser than 4 upon 12. 4 1 is 4, 4 3 is 12. X is lesser than 1 by 3. Okay, so x is greater than 1 by 4 and lesser than 1 by 3. Greater than 1 by 4, lesser than 1 by 3. Okay, so let me solve here. So this is actually 10 cube, 10 to the power 12x, 1 2 3 4. Oh, 10 to the power 4. Okay, 10 to the power 4. So 10, 10, 10 bases same, means we can compare the powers. 3 greater than 12x lesser than 10 to 4, 4. 10 to the power 4 means 4. Okay, we write here 4. So 3 upon 12, this x, 4 upon 12, isn't it? I'm comparing separately here. 3 1s are 3, 3 4s are 12, 4 1s are 4, 4 2s are 12. So this gives us x is greater than 1 by 4. 1 by 4 but lesser than 1 by 3. Okay, x is greater than 1 by 4 but lesser than 1 by 3, means the value of x lies in between 1 by 4 and 1 by 3. Okay, proved.